Well, good morning, everyone. Welcome to the C&E Sales Monthly Webinar Series. I'm Jeff Butler, the Technical Manager here at C&E. Today's webinar is titled Fortress amGardpro in Industrial Ethernet, and we'll focus on how to configure and communicate with these devices. Our presenter today is Steve Wright, Safety Specialist here at C&E. Steve has been with C&E for almost 10 years, and he holds a BSEE from Wright State University. He's a TUV Functional Safety Engineer and a Certified Safety Professional. Just a few housekeeping items before we start. If you have questions that come up during the webinar, please submit them using the control panel tool on the right side of your screen, and we'll address them at the end of the session. If you don't see that tool, click on the red arrow, red horizontal arrow, and it should open up the dashboard. Everyone registered for the webinar will receive a link to the recording, and so if you don't have a chance to take notes or for some reason you have to get up and leave, you can come back and pick up information later. Please be sure to attend next month's webinar. That'll be hosted by Scott Henry of C&E Sales. He's also one of our specialists, in this case on the automation side, and his topic will be IO-Link. The webinar will be hosted on July 12th at 10:30. I'll now turn today's webinar over to Steve Wright.
Thanks, Jeff. Morning, everybody. Today we're going to talk about the latest addition to the Fortress amGardpro series. They're what they refer to as their ProfiNet module, which allows some network communications to the amGardpro devices. Traditionally, you've always been able to connect to amGardpro units either through the two M20 conduit openings in the base of the unit. There are a number of different sizes of quick disconnects that can be specified and inserted in those openings. And still, in the past, you've been able to connect to these units via OSI network. But now, with these ProfiNet modules, we can connect to them either via Ethernet IP or through ProfiNet. I'm sorry, I have a little technical difficulty here getting the pages to work. There we go. So sort of what we're going to talk about today is there are a number of options for connecting the network and the power required for these units. There are some considerations that you need to be aware of when you're selecting your power connectors. And we'll take a little brief look at a amGardpro part number. One of the things I hear from a lot of customers is these part numbers are very long, and that's a function of the great flexibility you can in configuring a Fortress system. But we'll take a little look at one that might help you understand them a little better. And then finally, we're going to show you how I integrated a ProfiNet module into one of my PLC projects. So the ProfiNet module is actually added at the bottom of an amGardpro stack. And what you see on the right-hand side of the screen is a ProfiNet module with 4 buttons in it mounted to the bottom of a short lock body. You can actually add them either to a long lock body or a option pod and get a configuration similar to what you see on the left-hand side with up to 8 buttons, control buttons in there. In these pictures, I'm not showing any of the locks, but the normal arrangement of amGardpro lock bodies can also be added to this stack. There's space for up to 9 lock adapters, so these can be pretty complex and pretty large units. There are 7 really options for connecting the ProfiNet modules. You see across the top the 3 that are primarily used in Europe, that AIDA power connector and data connector is a connector that's specific to German domestic car production. It's used there a lot, but what we'll probably see most commonly here in North America would be any number of the 4 on the bottom. And you see really what they are multiple multiple versions of either 1 or 2 data ports and 1 or 2 power ports. There is also a possibility for connecting an external switch, another e-stop button or a guard switch that could be external from the ProfiNet module. And the only one's a little different is the PF11, which has larger power connectors. We'll see why that may be a possibility for you in a little bit. So if you look, just sort of examine for a moment how the power connections are made and what you need to consider should you build a geographically large daisy chain of ProfiNet modules. For example, if you look at the top of the page, you see some of the specifications for the unit that it requires 24 volts, but at a minimum, you have to put 21.5 volts on it. And in certain circumstances, it could draw up to 750 milliamps. So what Fortress has done to facilitate the arrangement of these is the power connectors actually have 2 pins internally connected, 2 for the 24 volt side, 2 for the common side. So what that means to us, next you see here a Turk RK 4.5 cord set is a common M12 5 conductor cord set that we sell here at C&E. It's got 22 gauge conductors. There's a little the resistivity number, and what all that comes together is, should I use a jumper those 2 connectors together, pins 1 to 4 and pins 2 to 3, I'm going to get a resistance value of 1/4 ohm per meter down that cable. So I think you sort of see where I'm going here. So for example, if I were to build a ProfiNet connection of daisy chaining 3 units to a power supply, what you see in bold at the bottom of the page there is the length in meters that separate each of the ProfiNet modules. And you see I could space them out pretty far, 20 meters and 15 meters in between them, and still get the requisite voltage to drive them all. This is just something to consider should you be putting these on a long conveyor line or a very large module. But also I'm using the PF10 connection with the smaller power connectors. The PF11 connectors might allow you to use larger conductors, so you could probably expand these even farther than what you see in this little example I came up with. So sometimes these Fortress part numbers can get pretty long and complicated, and sometimes if you're not experienced with them, they're difficult to understand. So I'll just break down a simple one here a little bit. This particular example doesn't have any lock adapters in it, just to keep it a little shorter, but you see how those little element abbreviations fit into the larger part number. It says I've got a Pro handle, short lock body, and configure the lock body in a certain way. I've selected it to be connected to ProfiNet, and I've added an e-stop, a couple of buttons, and an indicator to it. All the abbreviations come together. And as you might see, I've also selected down here the PF10 option, the 2 data ports and the 2 power ports. So this may help you a little bit when you're trying to decipher some of these numbers, but certainly call in here at C&E and we can fix you up with the unit you need. One of the strengths of these Fortress trap key systems is their extreme flexibility and adaptability. So we can come up with a configuration that'll do what you want to do. Just to navigate through the website a little bit to get to some of these products we're talking about. The web link at the top is actually to the Fortress Interlocks homepage. This is the product page for the amGardpro products. So if you step through these boxes that are shown in the red highlighted ovals, you're going to get down to a ProfiNet Ethernet IP page. And when you select there, you get to a product page that will show you some useful information and things you can download. You do need to register to download, but Fortress is very unobtrusive, and they don't share your email address with anybody, so it's pretty painless to register. And that'll allow you to download this, we see here, a data sheet, which will help you pick out the parts. Installation will show you some of the details of the wiring and the mounting of those units, and the Ethernet configuration booklet, which we'll talk about here, which steps through in a pretty direct, succinct, and comprehensible way the steps you have to go through to integrate one of these into an Ethernet IP network. Unfortunately, I don't have Ethernet IP equipment here, so what I do have is ProfiNet equipment, so we'll step through that process in a little more detail. You get to ProfiNet devices in a similar way from the home page, and you get to a similar looking page that has ProfiNet details on it, and we can download the GSD files here. The EDS files for Ethernet IP are soon to be available on the Ethernet IP page, but should you need one soon, I have one that I can send to you if you're going to do it that way. But next we'll step through a ProfiNet configuration that I did in a little more detail. So the first thing you would do is add that GSD file to your Siemens project, and you see on the right hand side where the amGardpro safety interlock appears in the hardware catalog underneath the general ProfiNet I/O devices. So we drag it into the network view and make the connections, which will allow us to assign the I/O, which is really what we're after here. And then in the device view of that, we're going to drag two modules out of the catalog, the safety module into slot 1, and the unfortunately named unsafe I/O data into slot 2. I'll refer to that as the standard I/O in the rest of this presentation, but you drag them into slots 1 and 2, and what I've done here is I've adjusted the addresses to all be contiguous just to facilitate my use of some of the data blocks we're going to create. So in the network view, I'm going to configure an IP address, and in the device view, I'm going to set the F destination address of this module, and it's going to match the dip switches that are found at the base of the unit. You see there I've selected 11 for my destination address. You also have to go online and set these things internally, but that should get you all the device connections you need. So how the I/O is assigned in either version of this unit, either the ProfiNet unit or the Ethernet IP unit, is as we see in this little graph here. So the byte 0 or the fail-safe inputs, the first 2 bits are the 2 channels of the condition of the solenoid and the head position. There's a non-contact switch that you can specify to be installed inside of a long lock body. This can also be replaced by the external switch connection should you choose that connector option, and 2 channels for the e-stop that's usually there. If you're familiar with Siemens nomenclature, the next byte is actually the value status, which means that these bits are all high when the unit is, the particular channel is not faulted and is reporting proper process values. What will happen is if you get either a short circuit or a discrepancy fault, one or both of these bits will be latched low. Just for your information, the discrepancy timing for the e-stop and for the door, the head and solenoid channels is 320 milliseconds. And the discrepancy timing for the non-contact switch is 4,000 milliseconds. But these should all be one if the unit is operating properly. If you want to reset all those, that's what Siemens refers to as a reintegration bit, which will reset all those should the discrepancy be cleared. And then I just show in the last group how all the standard I/O is arranged, starting in the top left and going through all the buttons pressed, the monitoring contacts, and the illumination, the outputs associated with those positions in the stack. And you see there at the bottom, if you can read all that, how I correlated it with my addressing. This is just another view that may give you a little context with a unit I've configured. In red are the fail-safe I/O, and in black is the standard I/O. You see in the upper left-hand corner just a little showing you how should you connect an external switch, what those pinouts are, and it's just 2 contacts on that external safety switch. So what I did for mine is I actually created 4 data types to control this unit with. This is just one way to do it. There are certainly lots of other ways to do it, but I'll just show you how I came up with it. So there are, as I say, 4 data types I created, 2 fail-safe, one for the ins, one for the outs, and likewise, one each for the inputs and the outputs of the standard I/O. This is just one way, as I named them and assigned them, for the safe inputs. A similar version for the safe outputs, those reintegration bits. And then the standard inputs I show there, and as you may suspect, the standard outputs. So with those, I create 4 PLC tags, one assigned to each of those 4 data types and mapped to the addresses I configured in my hardware there. The simple safety function block I created, you see what you're looking at is a declaration view of that. It's a pretty simple one. Again, like the data types, you can create these in any way you deem appropriate. I just created one for the fail-safe data. I thought it was simple enough that I could keep the standard data just by addressing the bits directly. So this is how I actually entered that function block in the ladder diagram. You just see that I can reset it from any one of 3 places, and then there's a few fail-safe outputs I chose to enunciate directly from it. What I assume in this one is that the unit is going to have an e-stop button in it, and perhaps not a non-contact switch. I just leave those non-contact inputs visible just to make sure that you don't forget about them, and I just set them up as true by default. You'll see as I get inside it how all that works. So if we look inside that function block, I'm just going to generate those fail-safe outputs. You know, the input, the I/O is okay if all the value status bits are in the run state. And then one of the things I do when I hit that reset input is to just cycle all those reintegration bits. Where the meat of it is actually here you see the input connected to a standard Siemens e-stop block, and just really configuring this to be manually reset should that e-stop go off. Likewise with the door locked and closed. For me, it's just a little more clear if I include those value status and the run state in those inputs just to make sure they're really working right. The non-contact switch is done a little differently. Some of you who are only using the simplest fail-safe function blocks in Siemens may be unfamiliar with the SF door block that works similarly but a little bit different than an e-stop block. How it works is the Q will go low whenever either of the ins go low, and it won't go high again until both inputs go low and then are sent high again. This particular one, if you look down at the bottom of it, the open NEC and the ACK NEC are just set false here. The open NEC would be at power up, I'd have to cycle the door to make sure it's working. And I don't have, because I've selected false for the acknowledgement, I don't have to acknowledge the fact that I've opened the door. It's going to essentially automatically reset. It's a little bit different, but it's just the way I did it. And then really what I do down at the bottom there in the network 6 to show that the head is actually closed and locked, just so I don't forget about it, is I include the status of my non-contact internal output with the actual closed and locked position of the door. And then finally, there's just I'm just going to get a signal if I need some acknowledgement. And again, perhaps it's a little more context to explain how the function block I created looks in the ladder. So that's kind of how you do one of those, but I want to mention to you that there, as I said before, a number of different ways to create these function blocks and use these. What you see on this page is a number of useful links that may help you navigate and get more quickly to the Siemens information that you need. The TIA selection tool is, if you haven't used that, is useful for building PLC racks and HMI equipment. We'll make sure you get all those necessary accessory pieces to complete your installation. The TIA portal list of links is a page that has a large number of links into it that are organized so that you may find them a little more quickly. Safety Advanced Configuring and Programming is the one document if you're actually using the safety programming that you need to be more familiar with. It'll show you, describe all the function blocks and the safety particular actions you need to do. For the 1200, there's a functional safety manual which is specific to the 1200. There's also some training videos that may give you some ideas about how to best use the fail-safe 1200s. And down at the bottom is the 1200 functional examples that contains a lot of examples of primarily door access applications. It's useful as a safety learning tool because it includes these flow diagrams and these function blocks and this validation information that's necessary for you to do if you're doing an accurate and complete risk assessment. And it shows you some of the wiring, and as I say, there are a number of different ways that these units can be connected and used. So this is a good place to get just a lot of examples that may be useful to you. So that's all I had to say today. If you have questions, we can stay here on the line and ask a few and answer a few of those, or there's my contact information should you want to write me or call me and with any other questions later. So I thank you for your time, and if I don't hear from you soon, I'll hear from you later. Bye.
Steve, thank you for the nice presentation. We currently do not have any questions that have been typed in, so let's wait for about a minute and see if we get any questions come through. If we don't, we'll go ahead and shut things down. I would like to let the listeners know that Steve is one of 13 different specialists here at C&E, and Steve his focus every day is machine safety. We have folks that focus on industrial automation, motion control, vision systems, and so there's all the various disciplines that we offer areas of expertise in. So if you have applications that you need some assistance with, please contact your C&E salesperson, and we can come on site and take a look at what you're trying to accomplish and see if we can help you out. Steve, no questions have come through, so with that, we'll go ahead and close the webinar down. Thank you again for the presentation, and thank you all for your time this morning.
Thanks for listening, guys.